Thank you, Tracy. So there's someone called Chris Anderson. Maybe some of you have heard of him before. But he was the editor of Wired and then also at The Economist. And so with all the lab automation talk that's been going on all day, the question often is, well, how do you bring down the barrier of adoption? And so for the last couple of years, first of all, there has been kind of this closed loop approach where we think lab automation really, can produce a lot of benefit. I mean, I think Emma has probably run some closed loop lab stuff, but many here have. I just know that, and at this point, you've all heard Bayesian optimization 15 times. So this is where you would use Bayesian optimization. Here, for example, from the University of British Columbia, they're trying to optimize some spray coating. So they have 5 stations, they have an arm, it moves around stuff. It works 24/7 when it doesn't break down. And then it will find after 170 experiments a really, high conductive spray coating combination. This is actually what it looks like here as well. I think you've seen this with Antonia's talk already. There's 7 parameters, you optimize it, and then the conductivity is maximized. Now, this is the idea of closed loop optimization or with self-driving labs. But how do you get started in it, right? It's like, do you just buy, a 150,000 pound KUKA robot? Probably not. I don't have that money at home. So instead, what people have coming up with, and Chris created the latest edition of this, is something he calls PocketSDL. I actually just took it out my pocket. Now I understand why it's called PocketSDL. But it's so small it fits in your pocket. And so this is what it looks like. So it's a 3D printed box. And this one costs apparently $40. I actually built something like this myself 3 years ago. It was $50. So Chris wins. So this is the PocketSDL. This one is also much, much more advanced. So this has this Wi-Fi chip in it, EPS32 or something. I think that rings a bell with some people. And as you can see, it has a light. So when I turn it on, there we go. You see it has a light here, and then it's ready to connect with your iPhone or Android or whatever. And then it drops you immediately into an interface where you can start running algorithms. Now, what it is that we're trying to optimize here? Well, it is a combination of red, green, and blue, which is kind of like the standard example people use to explain Bayesian optimization with. Tracy, I'm not sure if you can click on the link there, but select an app. Yeah, thank you. And so the PocketSDL basically brings all of that kind of closed-loop machinery into your pocket. Really cheap, $40, so you can play with it and especially kind of engage with the different algorithms there are. Antonio is still here, so he's working with all kind of algorithms, so is Laura, so are other people. Actually working with them in your hand is a different experience. So here's the virtual version of it. So I can say, I would like to use Bayesian optimization, and I want to have a different color. Let's say I want to find red, or let's say purple. I want purple. So this one here is the virtual simulator for that. So you see it's really trying to simulate with a nice animation. But it's taking different colors, it's mixing them, and it's trying to find the right combination to create the purple color. You see the experimental log. So we just got a mixture for, I don't know, what is that, greenish? And now it's mixing together something else that's even more green. And so with Bayesian optimization, it will try to maximize those 3, or optimize those 3 parameters, R, G, and B, to then actually get as close as possible to the color we want. And so the PocketSDL puts that all into a real-world system. What does it mean? You get measurement error, you get input error, and so all of that just makes it more tangible, and you can take it around. So it's a great training device. It is, of course, open source as well. So if you just Google PocketSDL, you can get the 3D print. You can get all of these things. You can work with that. That was shipped straight from San Francisco on FedEx Night Express, just so we could show it here today. So yeah, lab automation is taking over the world. Let's see how far I got. This is more purple. Oh, we are going for purple. Ah, we went down. Okay. Anyway, that's the point of Bayesian optimization. Not everything's a winner. Okay, that's it. So I think we can take 1 or 2 questions, and then we're going to have our sponsors finally present, so they can get ready here. We're going to have a little introduction from each one of them before we go into drinks. So any questions on this before we move into the section?
I love that it's still going in the background there.
Yeah, we just got to keep it running.
Yeah, any questions? I think we all just want to watch this thing go now.
How fast
Yeah,
does that happen?
I actually haven't found a way to make the virtual simulator faster, but obviously when I've built these systems, they can run in like 200 milliseconds per sample. So one version I've built is that the sensor would actually read it from the screen. This one has the sensor built in as well, but this is not a limiting factor. But what is very interesting is that, for example, you can take a light and you can shine into it, and that will disturb the measurements. So that's how you can like kind of get a real good feeling for what measurement noise means, right? So like the reason all of these people here produce really great robots is because we want to reduce measurement noise as well and input noise. So these are the things you can really tangibly explore just with PocketSDL.
Nice.
Okay, we're almost there, are we?
It looks pretty good. I think it's done. Success. On the right there, yeah. Fabulous.
Okay. Great, so with that, I'd like to invite the vendors on stage, so Tegan as well. So we're gonna have drinks right after the presentations, and this is how it works. You go on the first floor, you get your drink, then you go on the ground floor, where you get the crisps next to the Tegan stand, and then you can stay there, and then you come higher, and then you can talk to Opentrons, Thermo Fisher, Azenta, and Hamilton. Sounds like a plan? Good, okay. So who would like to introduce first? Neil? Yeah.
Come on up. Can we get a round of applause for the sponsors, all of them?
Yes.
Salesperson without a PowerPoint, here we go. So no more PowerPoints tonight. So my name's Neil Foskett. I'm a sales manager for Thermo Fisher Scientific on the lab automation side. So Thermo, as you alluded to, is quite a big company. So we're 44 billion, 125,000 people, 1.4 billion spent on R&D. A lot of that is going into AI now, and lab automation is a big growth for us. For me, I've 23 years in the company, coming from CO2 incubators, and you're right, they're not 300 pounds. Thank goodness. But one of the things I love about this, and salespeople come around to see you and thinking, oh no, coming to sell me something again. It's really about collaboration now. I've been working, if we take COVID today, it's been talked about a lot. One of the things that automation really helped with COVID is you saw on the news all of those thousands and tens of thousands of tests that were done every day in the car parks with the swabs. Those poor lab people working 24 hours a day, doing thousands of tests a day. We worked with the local government to put together all of those different pieces of equipment, automated it, and then we came up with a product called the Amplitude, which was all those pieces of equipment pushed together using AI and using lots of technology. And we managed to have one machine that could churn out 8,000 tests a day, on each machine. So that really helped to clean up what was going on out there, which was pretty horrific. And also kept the scientists and the lab people safe as well. So we used standard incubators to deactivate the COVID. So when it went in, when they were doing the test, they went from working in fume hoods, completely gowned up, to just being able to stand there and look at the machine at a safe level, take the sample, test it, and then safely dispose of it. Also been working with lab automation on simple incubators where cell gene therapy now, as we've talked about today, it's hard to scale, it's very expensive. So when I've been to see some customers, said, all we want is you to automatically open the door on the incubator. Nice and simple. So we just took our standard incubator and opened the door. So when the robot comes up, it trips the door to open and it puts the G-Rex inside. So we can scale up. A lot of the contamination comes from people with CO2 incubators. When that door opens up, everything floods out and everything floods in. Just using robots, you can scale up, you can keep everything nice and clean, and you can take a lot of cost out of that manufacturing as well, which is obviously very key for some of these novel drugs. So I say I'm not here to sell you anything. I think one of the things that we need to talk about is collaboration. So when I go to see customers now, it's not just about what Thermo Fisher Scientific can sell you. You know, we work with other people in this room today, and we even work with competitors now, which maybe we wouldn't have done a few years ago. But to give you the true solutions that we need now, we have to work with people we probably wouldn't work with a few years ago. But that helps you, and it helps us in the long term to collaborate and bring out that next generation help for that drug discovery. And I've probably gone over time, so I'll leave it there. Didn't sell you anything, so there we go.
Not yet. Thank you very much. All right. Next we have Opentrons. I'm not sure if Opentrons has.
Opentrons, yeah.
So Dan.
Dan, are you speaking for Opentrons?
Yes. So Opentrons have been the very, very first supporters of the London Lab automation community, the very first event and many after that. So it's great to have you guys here again.
And it's great to be here, thank you. So we're Opentrons, as it's been said. The real thing for us today is the community. So it is the people in the labs who are automating science. I assume that a lot of people are familiar with Opentrons. If you're not, put your hand up. So come and speak to us, and we'll give you a tour and tell you exactly what Opentrons is. But just for the next 30 seconds, what we are working on, what we're trying to do is to enable scientists, enable engineers, so the community here, to really go from intent. So your scientific idea, that might be something that you have just come up with, it might be an SOP that you have, getting from that intent to the execution. So how quickly can you put that onto a piece of automation? We really want to shorten that time. So just make it so that you can scale up, you can do more in a smaller amount of time. So come and have a chat with us, find out what we're doing with the tools that we're developing. So Opentrons AI, the protocol designer, protocol visualization, that enable you to do more science faster.
Amazing, thank you so much. Okay, do we have a Hamilton, a little introduction? And then a Zenta and Tegan after that.
Hi everyone, so my name is Sarah Dickinson and I'm one of the territory managers with Hamilton Robotics in the UK. I'm sure most people have heard of Hamilton in some sense, whether it's been the robotics, process analytics, Hamilton Medical. First of all, this is the first event of this type I've attended, and I just want to say thank you to the organisers and to all of you guys that have come and spoken to us. I think for me personally, obviously working in sales for the last 14 years, people think, oh God, you're just a salesperson, but actually being involved and seeing some of the stuff that all you guys are doing in the room, and it's really exciting, and it's lovely to be part of it, and it's lovely to see what sort of the future holds, and for research and technology and everything. So although us salespeople are, annoying you and stuff quite a lot of the time, it really is, gives us a lot of joy to be part of your journey and to see you guys grow and stuff. So thank you very much for that.
Amazing, thank you.
Thank you.
Good. Zenta? Yes, Leah.
Okay, yeah. Just in the break, I'll just say that it is really helpful. I mean, this community doesn't happen without our sponsorship at all, so we do really value everyone for being here.
It's my turn now.
Yeah.
Hi everyone, I'm Leah, and I'm representing Azenta today. I've been to the lab automation events many times, never as Azenta, and mostly as an engineer. Today we've got sample management, we've got a few devices. I've brought my colleague Justin, give us a wave. I think our energy is low, so I'm not going to try and sell you anything, but come and take a free visit, okay? And give me your email address, I'll send you some free samples. Yeah? Thank you.
Thanks,
Mr. Tegan?
Oh, yeah.
Oh.
I didn't see me sneaking down the stairs, trying to be subtle. I know, I wasn't really. So hi, I'm Aletia. I'm from TCAN. I've been with the company since 2003, actually. Started as an application specialist and then moved into sales because the pandemic was just exhausting for us.
I fancied a change. We focus very much on adaptability, scalability. This event is perfect for us. We do everything from really small digital dispensers, cell dispensers, plate readers, all the way up to massive liquid handlers with big storage devices on the side, and we've recently moved into the robotic work cell space as well. So we can take you through that entire journey from your really small scale to the point where you're actually creating that full automated laboratory. We're upstairs, we're lonely, come and say hi. Thank you.
Thank you. Okay. So yeah, this is the sponsors. They have really made this possible. They were here from the beginning to the end. We're now going to do the drinks, which are ready on the first floor. Again, there is a procession. So first floor drink, second floor crisp, and then the ground floor and the basement here for the networking. This is ultimately what it's about. We always try to keep the talks very short because people are here to talk and meet new people instead of learning everything new. So yeah.
Yeah. I'd just like to say thanks to everyone. Yeah, and look forward to networking with you all.
See you soon.